Okay, so today we are on day 22 of solving data structure and algorithm problems. Yesterday we have solved kth smallest element in a BST in an efficient way and also constructed a binary tree from pre-order and in-order transversal. So today we will be trying to solve these two problems. First one is binary tree maximum path. Let me open this first. Okay, so I have a submission for this problem which was in June 22. So before that I had couple of wrong submissions. So let's read out the problem. So the problem says a path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. A node can appear in the sequence at most once. Note that the node does not need to pass through the root. The path sum of a path is the sum of the node's value in the path. Given the root of a binary tree, return maximum path sum of any non-empty path. Okay, for this tree, the path is 2, 1 and 3. So maximum sum is 6. Okay. And for this particular problem, the optimal path is 15, 20 and 7. Suppose if we try to took another path like 9, minus 10, 20, 15 or 9, minus 10, 27. So that will be smaller than this sum, means this subtree 15, 20 and 7. Okay, so our node values are in between this and total number of nodes are 1 and 3 into 10 raised to the power 4. Okay, we need path with the maximum sum. A path in a binary tree is a sequence of nodes where each pair of adjacent node in the sequence has an edge connecting them. A node can appear in the sequence at most one. Note that the path doesn't need to be passed through the root value. Okay. So suppose there is a node connected. If there is a node connected under 15 as minus 3. So in that case also this will be our maximum path. Okay. Mm, so as of brute force solution, what we can do here is we can transverse tree And for every node, we'll calculate left's maximum on left, maximum on left, maximum on right, and plus current node. So we can assume that after traversing the route, we can consider every node as a root, and we can calculate the sum of the left maximum sum in the left part and maximum sum in the right part. So let's I think we should implement brute force approach first. So now we need to think of optimized approach. So this will take a big off and scare time. Okay, so now we need to think a optimized solution where we can solve somewhere between big O and 2 maybe and log n time. So let's take this example. Let's take a left children for the 15 node b minus 3. Okay, so we have added minus 3 as the left child of 15. I think their UI is not working good. Okay, so now it's working good. After zooming in, UI is getting distorted. So suppose here for 15 we will check the maximum path on the left. So maximum path on the left will be minus 3 and on the right will be 0. So considering 15 as the root, what will be supposed to return is we need to return 15 because adding a negative value will decrease our path sum. So instead of returning minus 0, minus 3, our call will return a 0. Okay, so we have written a 0 here. So now we will check if our current sum is greater than 0 or not. So yes, 15 is greater, so here we will return 15 and from right side we will return 7. So now our sum becomes this value 15 20 which is 35, 35 plus 7 42. 42. We will return 42 here. 42 plus 7 42. 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 Okay, so what we'll gonna return here is we will going to return 20 plus 15 because this part has a maximum sum. Okay, instead of current sum, we will be returning uh, maximum of left sum plus right sum and current sum. So that will be sum for here. Okay. Suppose my right child is 5. So my left call will return 0, right call will return 5. Okay. Now I will return max of current value 15 plus max of left and right. So which is 5. So 15 plus 20. So I will return 20 here. And from here I can return 7. So I think this approach can work. We will iterate tree from bottom and will find current sum as the current node dot value plus maximum of 0 and sum on the left part plus maximum of mm, let's say we maximum of left and right. And for the above root, uh, suppose our current node is 15, so maximum on the left is 0 and right is 5. So for the next call, which is 20, what we will return is we will return the current node's value maximum of 0 and current node's value plus maximum of left part sum and right part sum. I think this approach can work. And I can take a global variable where I can store the maximum of current max. Suppose current sum and max sum itself. Okay, so I think we can start implementing. So I'm thinking, should I also implement brute force approach, or I can just jump onto the optimized approach? Okay, so I think we should first implement brute force approach. Okay, so let's implement the optimized approach. So we will call a function. Okay, so what we will gonna do here is we have called this function util function tree node root. Okay, so if our base case is if our root becomes null, then in that case we will return. Okay, so let's take this as an variable. Okay, so what we need to do is we need to calculate the maximum path on the left and maximum path on the right. So we will make a call for left node and right node. So int left is equals to root dot left and int right is equals to root dot right. Okay, so we have a transverse left part and right part. Okay, so after transversing both the parts, after when our call ends, means when our transversal when we have transverse left part and right part. In this case, suppose we have transversed one's left part and one's right part. So what will be our maximum sum? So our maximum sum will be max of uh, current node's value plus its left max plus its right max. Okay, and one thing we can also check here is suppose our all nodes are negative, so in that case we can't return an empty path, so we have to return the node with the maximum value. So here we can do is we can also put this put like this. So what we are doing here is we can also considering current roots value, current nodes value, so that we can't get a empty path. So we initialize max path sum as a integer dot min value, and at the end we can return this max sum. Okay, so we have found the left part and right part sum. So suppose for the suppose if one was here, so for the next wall we need to return the maximum. So what we will do is we will return math.max of 0 n math.max of okay, so left part will return sum on the left part, right part will return sum on the right part, and our maximum will be current roots value and maximum of current roots value plus okay, so what we need here, okay, now we Suppose we need to return, we are at 20 and we need to return maximum value from here. So we will choose that either it's 0 in the case it's a negative number, and otherwise it will be maximum of current roots value plus maximum of the left part and right part. So I think this should work. I think I need to connect internet. Okay, so we got a submission. So I think that is it for today. So we have solved this problem also. So tomorrow we will target to solve the tree part. Okay, thank you guys.